Hello, this is Arthur Teasy, CEO of MeaningBot. Today we're going to talk about what is a very important issue related to artificial intelligence, which is explainability. So our agenda will include a brief high-level definition of AI and its applications, what explainability is and why explainable AI is important, how to achieve it, various foci from a standpoint of users of explainability, and then the challenges and trade-offs. So let's first talk about what AI is. And AI is really defined as intelligence demonstrated by a man-made object. And the object may be a robot, it may be a computer, it may be a small script or a sophisticated learning algorithm, but basically the ability to make decisions based on interpreting given information would make a machine intelligent. And if we take a look at the history of science, the tasks defined to be intelligent for machines continue to change and evolve. So some time ago, optical character recognition, or OCR, was one of the very difficult tasks, and now it's really not even considered to be significant in terms of artificial intelligence. And the evolution of machine learning has enabled us to solve many of the AI problems that were once considered impossible to solve. And machine learning is one of the subdomains of artificial intelligence, with others including robotics and rule-based intelligence, sensing, automated planning, knowledge representation and reasoning, and so on. And AI draws upon a very diverse range of fields like computer engineering, information systems, mathematics, probability models, psychology, linguistics, image analysis. And it's really largely inspired by the abilities of humans, such as a brain function or body movement. So it really is really growing based on the intersection of the ability to solve a lot of this mathematically, but also apply processing horsepower with enormous amounts of data, so you have this three-legged stool to act upon. Artificial intelligence has applications in a wide variety of domains, right? Starting from climate control and climate change in closed places to understanding, generating, and processing natural language, deciphering structured as well as unstructured data, and the like. And AI systems have become very versatile and are making their way into almost every imaginable industry out there, right? Large computing processing capacity has helped AI in reducing these mundane and tedious tasks that humans have to perform on a day-to-day basis. Okay, so AI is very useful and it helps us make our life easier and allows us to focus on high yield, uniquely human tasks, and that's great. But oftentimes the algorithms don't really tell us why they did what they did or how they did what they did. So consider a simple example of image processing, right? We built a classifier to detect if a dog is present in a picture or not. And the algorithm only gives us an answer to whether or not the dog is present or not, but it doesn't have any explanation to why or how it concludes the presence or absence of that dog. Now, this is a trivial example, and probably we won't even need to know why the algorithm made such a decision, but consider another AI application. The machine learning system that looks at a video of an applicant interviewing for a job and decides whether the applicant would be a good fit or not. Now, in such a critical application, the applicant would definitely want to know why the system accepted or rejected him or her. A recruiter would want to know which element of the video did the system consider while making this decision, and an employer would need to understand the decision process to keep bias in check and have a fair review system and make sure the system is giving them what they are looking for. And this is where explainability of AI comes into play. AI explainability is a multidisciplinary concept and largely depends on the domain of the application. The need and extent of explainability changes with the domain and the application, and we still lack to this day an agreed upon definition of what explainable AI is. In some applications, a basic look into decision-making processes are sufficient, while in others, even a detailed, in-depth review of model parameters would not suffice. But in general, explainable AI is supposed to explain the decision-making process, right? What steps it has taken to reach what conclusion, disclosing the information that it has used to arrive to a particular conclusion, explain its capabilities, what it understands, what are its blind spots. And many times, due to complexity of these algorithms, it's not possible to provide explanations in full. Other times, companies don't want to provide the explainability. They want to keep things black box. And in these cases, even partial explanations can really work wonders and are helpful in communicating the why behind the decision. As the applications of AI are increasing daily and they are entering domains which impact humans critically, the need for explainable AI is constantly increasing, right? So this, quote unquote, this right to explanation under certain circumstances are now included under many data privacy acts, including GDPR. And currently, these acts mostly focus on legal and financial domain, but it's not far from the future that these acts will extend to other domains. So AI today is very, very capable. It offers a lot of potential to help humans make their life easier, convenient, fair, and faster. And although we find researchers pitching for AI in various new domains of application, we also find a vast majority of people who don't have much trust in AI. The lack of trust comes based on the partial knowledge about AI and a fear of AI overtaking us in many of the abilities and things that ultimately could potentially outgrow humans. Making AI explainable would go a long way in building this trust. Once the logic behind the AI decision-making process is clear, it becomes far less intimidating and much more appealing. And this explainability, in addition to the curiosity about AI, could really help drive the AI revolution further. Once these learning machines become more explainable, researchers can understand them better and can understand their capabilities. And this understanding of their capabilities can help in extrapolating their applications and help in transferring the learning of these applications to new domains. So getting to know the capabilities of these machines would also enable us to know their blind spots. This can be very helpful in deciding where the human intervention is necessary, where not to use a particular algorithm, and on which areas to focus the new research. Explanations behind the decisions made by machines reveal what is the information they are working on. This information helps in identifying if the algorithms are acting on wrong information, if that creates bias that will be inherent in the system, and so on. And once this bias is found, only then would it be possible to fight against it, to kind of focus on it, to eliminate it. Humans are inherently biased about a vast majority of things, and if these algorithms aren't, they can prove to be a very rational counterpart in critical decision-making processes. However, we have to work and strive to avoid and eliminate the inherent human bias in the development of these algorithms. So if you think about the AI development life cycle, it really can be broken down into 3 stages. And those are namely pre-modeling, modeling, and post-modeling. And we can actually introduce explainability into any of these stages. Now, the behavior of AI models to a large extent is driven by the data set used to train it. And that means that if we understand the data used to train the model better, we'd be in a much better position to explain the model itself. And pre-modeling explainability consists of understanding the data, checking its parameters, checking the bias or the skews in the data, which would eventually be picked up by the algorithm, building and then building explainable and meaningful features. Visualizing the data is an important component in understanding data features and comparing them. Things like mean, standard deviations, class imbalances, and the like. If we know the blind spots of the algorithms we're planning to use, then checking data for these vulnerabilities becomes really important and very valuable. There are various methods of visualization of multidimensional data that are available, and they would all fall under the umbrella of pre-modeling explainability. The step after the data understanding is the actual model development, and this is the stage that's critical in deciding the extent to which an AI system can become explainable. And this step is not as straightforward as simply choosing a model from an explainable family of models, right? The model's explainability depends on a large number of variables, including the data set dimensions, the applications, the features, and the like. In addition, we have to kind of battle this trade-off known as performance versus explainability, right? So current algorithms fall under the category of the notion, for example, that the more accurate the model gets, the less explainable it becomes. And this comes from the fact that real-world problems are complex, and they require complex data transfers, which lead to a lack of explainability or a leakage of explainability. And a considerable part of the explainability research, or the XAI research, is focused on developing more accurate as well as more explainable models. But the reality of today's world is that most of the AI models out there are already developed and deployed with only predictive performance in mind. So explainability is something new that we have to tackle more aggressively. The issue of explainability arose later on, and now suddenly these models needed to be explainable as well. And this is where the post-modeling explainability becomes very handy. This is the most researched area in AI explainability, and it's really a focus from a research perspective of many educational, industrial institutions. Post-modeling explainability aims at making sense of model parameters, visualizing the model parameters to seek these visual cues for explanation. And there are some model agnostic methods out there that aim to explain the decisions made by complex AI algorithms. And of course, they come with a cost in terms of the restricted, reduced accuracy. Okay, so a word on users of explainability. So depending on who is asking for an explanation, the depth and focus of the explanation would and should change. If the end user needs an explanation, it would really be preferable to explain the why behind the decision-making process, assuming usually minimal technical knowledge. So whether you're talking to an AI engineer versus an IO psychologist, you're going to have a different lens from which to look at this. But this would involve the need to translate mathematical and probabilistic explanations to a kind of domain-specific natural language. On the other hand, if the developer of the system is asking for an explanation, it really should focus on the how behind the decision. And these decisions in terms of the explanation and these actual explanations can be as technical and mathematical as necessary and required. Moderators of the system would kind of sit somewhere in between end users and developers in terms of their overall, in terms of the overall approach to the the user base. And they might need a different focus of explanation that would enable them to assess bias, for example, and fairness to the system. So as we mentioned earlier, there really is, as they say, no free lunch. And so explainable AI systems do come with trade-offs. They come with costs that are associated with that degree of explainability. And the biggest limitation today is the explainability versus the accuracy trade-off. There seems to be an inherent conflict between accuracy and explainability for AI models that are available today. And in the process of trying to capture more and more complex patterns of real-world problems, these models lose their explainability. Many complex models do have the mathematical or probabilistic explanation, but translating that to domain-specific explanations in natural language is really a challenge, significant and often daunting task. Automating this translation requires more machine learning application of problems and making them explainable, but it also then, again, the corollary is it definitely throws us into challenges associated with the deeper explainability. Explaining the decisions made by AI models seems easier when compared to the task of, for example, explaining the competencies and blind spots of AI models. Explaining the ability of AI models to reflect on unseen problems, for example, does require an in-depth understanding of the model parameters. And the more complex these models get, the more difficult the understanding becomes. So even if we do achieve the explainability, evaluating these explanations can still be subjective. And most measures out there use a benchmark associated with user satisfaction as their sole metric. And that obviously introduces a lot of variability in terms of the differences of what user satisfaction means depending on the type. So thank you for watching this presentation. If you want additional information with additional supplemental links, please go to meaningbot.com/reference materials, and there you will find links to various supporting materials related to this presentation. If you'd like more information, please contact me directly at arthur.tc@meaningbot.com. Thank you.